Hello. So we are moving to the passive circuit elements. Okay. Introduction is completed for the passive circuit elements. What are the passive elements? Resistor, inductor, and capacitor. Let us discuss resistors. Okay. So resistance or resistor is a electrical component in. Okay, it is an electrical component, right? With a specified value. For example, in a particular circuit, 1 ohm resistance is there, 100 ohm resistance is there. That is a specified value. That particular resistor is an electrical component. It is a specified resistance, value of resistance. It is probably most common component in all kinds of. For example, you are taking any electronic component, electronic equipment, it is having resistors. Without resistance there is no component, electronic component. So the values are ranging from small, maybe it is a ranging from small radio to color television receivers. Everywhere this resistance is present. So the way the resistances are, this is a resistance, this is a resistance, this type of this different resistors we have. Okay, resistance, with the property itself, it opposes the flow of current. Very important. Resistance opposes the flow of current. In the introduction, I will give the 3 important points to you. Everyone remember the first point here. Resistance opposes flow of current. Opposes flow of current. Okay. So another point I mentioned in the introduction, it is also very important. Inductor opposes sudden change in current. Sudden change in current. Everyone is following. So third one, capacitor opposes sudden change in voltage. Sudden change in voltage. You will see these 2 points later in the inductor and capacitor class. Now here the important point, resistor is a resist or opposes flow of current. Okay, it is one of the important question for your examination in the past 2017 question paper and 2016 question paper. One question, one for inductor, other for resistance. Questions are present. So it is also expected question, maybe capacitance is given in the 2022 examination. So mark in your notebook, it is an important point. Okay, resistance is necessary, right? For example, without it is a useful in the resistance in the circuit itself. In case without resistance, what will happen here? Without resistance, for example, there is no resistance in the circuit. What will happen? Every circuit should be short circuited. Without resistance, every circuit should be short circuited. That is there. So that's why resistance is one of the important component in the circuit. Okay, what does resistance? What are the properties? What is the common proper values of circuit what we call, what is the useful work it is done? What is the useful work for resistor? I will explain. For example, I will take some resistance and then voltage. This is connected to one lamp, for example. Right, this is the lamp I have. So what does resistance is doing here? So the first thing, some of the common proper value of circuit voltages due to IR drops. For example, I am connected here 230 volt. The reading of bulb is 110 volt. I need to drop here IR drop. That IR drop is equal to 120 volt. That means that resistance, that value of resistance I connected, this bulb is working safely. That means this is the point here. To establish the proper values of circuit voltages due to IR drops. Okay, it is done. That is the first thing resistance is doing. All of you clear? Next, what about here, to limit the current also? If you are connected some rheostat or like that, we can limit the current also with the help of the rheostat. And then that is also resistance, one type of resistance to provide the load. For example, here bulb is not there. In place of bulb, I connected some load, some variable resistance, it is act as a load. Instead of you are connected some bulb, I am connected some resistance, that is act as a load. So that is also another point, it to provide the load. Okay, these are the important points you need to remember. So the two main characteristics of resistance and characteristics is resistance and power rating. Every resistance having some power rating, some of the resistances having power rating. So that is one of the important point. Resistance can be connected in the circuit either direction. So what is the either direction means? For example, in this circuit, what is the polarity of resistance? Positive and negative. If I replace this positive and negative of the battery to negative and positive, if I connected like that, okay, if I disconnected these two, I connected here negative and positive. So what happened for this polarity? Negative, here positive. All of it clear? That means, so I am taking this particular resistor without connecting any circuit. What about the polarity? You can't decide it. That means resistance not having any polarity. Very important. Not having any polarity. So it having polarity based on the polarities are depending upon the supply voltage or supply you are connected. So that means the direction of current is decided. So that's why that is a point. It can be connected in any direction because there is no polarity. Okay, this is about resistance concept. Okay, you need to remember these points only. The first point, resistance opposes the flow of current. Without resistance, circuit would be short circuited. So it provides the three functions. The first function is it provides the IR drop, and then it also limit the current. It also provide the load to the circuit whenever it is required. So it is not having any polarity. Okay, these are the points is in. Okay, next we are moving to the resistor types. So what are the different type of resistors we have? So look at here. Resistors mainly two types. What are the types here? Wire wound resistors and carbon resistors. Other one is a metal film resistor. Okay, these are the resistor types. So mainly two types, wire wound and carbon resistors are very important. In the carbon resistor itself, carbon composition type, carbon film type, ceramic film type. These are the three different types after in the classification of carbon resistors. Let us see one by one. Maybe what are the questions we are expected from this particular topic. I will explain meanwhile while I am explaining the resistors, different type of resistors. So look at here. The first one is a wire wound resistor. So in your laboratories, while you are doing your experiments, this type of resistors you may know. Okay, maybe just recall the resistor while you are doing the experiments. In this particular case, by looking at this particular what we call particular wire wound resistor, that particular wire is wounded in a coil. That's what here they are constructed from a long fine wire. Okay, that wire usually nickel chromium, very important. Nickel chromium wire is used, wound on a ceramic core. So this particular core wounded on a this particular wire, nickel chromium wire. Okay, the length. Okay, how to decide the resistance value? The resistance value decided based on the length of the wire you are using and resistivity of the wire. Resistivity, that is a rho, as well as length, because R is equal to rho L by A. So the resistance value is depending upon the length of wire you are using as well as specific resistance of your wire. It can be decided. That's what here the length of the wire used and resistivity determine the resistance of a unit. Okay, the wire is a bare, that means there is no plastic insulation outside, that is a bare. So but entire assembly is covered or coated with a ceramic material or special enamel coating is there, na? That's what here. So this is about wire wound resistor. Okay, what is the range of in the examination they are asking what is the range of wire wound resistor is used. That is also important. In case of power rating, In case of power rating, generally power ratings from 5 watt to several hundred watts. We are using this particular wire wound resistor, 5 watts to several hundred watts. And what about resistance value from 1 ohm to 100 kilo ohm? 1 ohm to 100 kilo ohm, we are using this particular wire wound resistor. So the wire wound resistors are used where it is used. It is used in the two cases. The first one, large power dissipation is necessary. For example, you want to dissipate the maximum while you are doing a electrical experiment like machines, right? In the machines experiment, you want to connect the shunt resistance in series with some wire wound resistor is connected. Just recall those those circuits while you are doing the speed control of DC motor, like, right? So large power dissipation is necessary, and precise and stable resistance values are required for the meter shunt and multipliers. What is mean by shunt? Already mentioned. Shunt is nothing but a parallel. You want to connect the parallel cases, that is a shunt and multipliers. So in that particular cases, we are using this particular wire wound resistor. So in the measuring instruments, to extend the range of ammeter and to extend the range of voltmeter, you are using the shunts and multiplier concept there. So I will explain in the unit 5 instrumentation is there, one of the chapter we have. In that we will discuss in detail. Still now it is enough for wire wound resistor. Then we are moving to the next one, carbon composition resistor. Maximum electronic students in your EDC, this in your EDC lab, this particular resistors, almost this particular resistors and everything. Just look at your diagram. These are the representation for resistors. Their color coding is present. After few minutes, we are going to discuss the color coding concept also. Okay. Meanwhile, just listen what is meant by carbon composition resistors. So by look at here, this carbon composition resistor bar color coding, okay, as well as solid resistance element, as well as a tinned leads. These are the leads to connect it in the circuit, and a solid resistance element. If you are cut the particular carbon composition resistance, inside we have a solid resistance element is present. So just look at the point wise. They are made up of a finely dividend carbon mixed with the powder insulating material in the suitable portion. This particular carbon composition. The resistance element is a simple rod of pressed. This particular element is a simple rod pressed in a carbon granules, which usually enclosed in a plastic case. This total entire structure enclosed with a plastic case for insulation and mechanical strength. Okay, right. Their two ends are there of the carbon resistance element joined to metal clamps. Okay, with leads tin wire for soldering connections into the circuit. Okay, in case of circuits we have, you need to solder, right? In the PCB printed circuit board, you need to solder these particular resistors. You are using two leads. Okay, this is about the carbon composition resistor. What about the ratings? So this particular carbon compound resistors are usually 1 by 10, 1 by 8, 1 by 4, 1 by 2, like 1 watt and 2 watts. They are using up to 2 watts. Okay, what about resistances? Resistance values of 1 ohm to 220 mega ohm values resistance. So usually power dissipation is 2 watt or less. We are using such resistors are preferred. Okay, these resistors only preferred 2 watt or less than 2 watt only. Okay, so as well as these are smaller and costless. Just 50 paisa, 1 rupee. It is not more than that. This particular resistors. It is a smaller and costless. Carbon resistor with power rating of 1 watt or less, most common in electronic equipments. In electronic equipment, these are the resistors are present less than 1 watt. Usually it is used in the electronic circuits. Okay, now all of you clear about the two resistors, right? First one is a wire wound resistor. These are used from 1 ohm to 100 kilo ohm. Wattage is 5 watt to several watt. In case less than 2 watt, we are using the carbon composition resistance, but resistance values are 1 ohm to 20 mega ohms. It is very high values of resistances. Next, carbon film resistor, it is a part of, just now I mentioned that, you know, carbon resistors only divided to carbon composition type, carbon film type, ceramic film type. All three are categories from the carbon resistor, just small modification only. That's what these two elements we are going to see. Carbon film resistor, this is a small difference here from the carbon composition. Instead of carbon composition, you are using high grade ceramic rod core which deposited on the film, resistive film of carbon. That's why it is a carbon film resistor. It is cheaper than the composition resistors. Okay, it is enough for this particular carbon film resistor. What is the difference from the carbon composition? We are deposited the resistive film carbon for the high grade ceramic rod. Okay, next one, cement film resistor. It is also category from carbon resistance only, one of the category. It is a, instead of you are using the resistive film carbon, you are using the thin carbon coating fired on a solid ceramic substrate. Okay, the main purpose, for example, you are using precise and the accurate value of resistance you are using, this particular ceramic resistors are useful. It is a greater stability to heat. For example, we are using the particular equipment, for example your electronic equipment, you are using 1 hour, 2 hour, 3 hours, 4 hours. What will happen? Heat will be generated, right? In that particular cases, we are greater stability with this particular resistance is a greater stability to heat. Okay, it is not changing the values of resistance even though heat is generated very high. This particular cases, ceramic filament resistor film resistance are used. Very often they are made up of small square leads with leads to fit into the printed circuit board. Already mentioned PCB, printed circuit board. In that particular board, you need to insert this particular ceramic filament resistor. We are using the small leads in the outside of this ceramic film resistor. Okay, this is enough for this ceramic film resistor. Then you are moving to the last step, metal film resistor. Look at here, these are the metal film resistors. So in this case, what is the difference between the both carbon composition or wire wound? It is somewhat different here. They are preferred for thin film resistor. As to thin film resistor, they consist of a thin metal coating deposit on a cylindrical insulator. Okay, so the high resistance values due to thickness of the film, because you know it is a difficult to produce the films of a uniform thicknesses. What is the main problem here? You are not uniformly, in case of carbon wound resistor, okay, we are based on the winding, you can decide whether it is a resistance values, but it is a difficult to thin film resistance is a difficult because your different films are inserted. So it is a difficult to uniform thickness of all films, what we are mentioning, placed in the particular resistor. That's what here, not possible to control the resistance values accurately in case of wire wound resistor. In the wire wound resistor, we can control the resistance values, but it is not possible. But only one case it is using there, where you know free trouble to some inductance effects. In case of wire wound resistor, inductance effect is present, but where you need to require free from trouble someone in inductance effect, some inductance effect, we are using the metal film resistor. So in case of wire wound resistor, practically very particularly at high frequencies, we have a problem with inductances. So we want to avoid those problems, we are using the metal film resistor. So this is about different type of resistors. I hope that you got the idea about the somewhat resistance concepts, right? So okay, next we are moving to the power rating. It is also very very important. So by look at these diagrams, you know, it is a length, it is a circumference, as well as surface area is equal to L into C. Okay, this is a particular diagram. Color coding is also mentioned. But in case of power rating, see here, the power rating of a resistor is given by the maximum wattage it can be dissipate without excessive heat. That means, for example, in case of resistor, it mentioned the power rating, 1 watt or 1/2 watt or 2 watt or 5 watt. It is mentioned in the power rating of a resistor power rating. So that means it is indirectly, it is a withstand for the particular wattage. so without generating the excessive amount of heat. In case it is see that if it is current produces heat, power rating also gives some indication that maximum current a resistor can be safely carried. That means that power rating also indicated that it can be safely carry the current with the maximum amount of heat is produced. It is within the limits, it is carry safely. Okay. Next, another thing, if current exists, for example, the current excess flowing through the particular resistor, what will happen? More heat will be generated, produced than the carried safely, as the resistance will be burned. Very important. If you are connected particular resistor, very high amount of is flowing rather than indicated power rating, that means resistance going to be burned. With the help of the example, we'll see. For example, 1 by 2 watt, 1 by 2 of 2 watt of a heat without damage, whereas a 1 watt resistor can be thrown off twice as much of heat. For example, you have a 1 watt resistor replaced by 1 by 2 watt resistor in the circuit, for example. In that case, there is no problem. So it carries a safely amount of power rating, everything. But in the sense of, in case you may substitute 1 watt resistor same as the value of 1 by 2 watt resistor. For example, you are taking the resistance value, you want resistance value of 20 ohms, for example. Okay. We have a two resistors, 20 ohms 1 watt resistor, 1 by 2 watt resistor, again 20 ohms 1 watt resistor. Resistance is same, just observe here, resistance is same. That's why, for example, 20 ohms resistor 1 watt is available in the market. I don't have a 1 by 2 watt in the market. I can take this particular resistor and then I connect it in the circuit, no problem at all, because you are designed 1 by 2 watt, you are using the 1 watt without there is no problem of excessive heat. In case in the market you want in the circuit is 20 ohms 1 watt resistor, but in the market it is available 20 ohms 1 by 2 watt resistor, you may take that particular resistor. If you are connected particular resistor in your circuit, what will happen? Excessive amount of heat will be generated. Your circuit going to be, your particular resistor going to be burned, because excessive amount of heat will be generated. All of you got my point? Even though your resistance rating is same, but don't use wattage rating less than the specified value. That's what it is mentioned in this particular point. After that, by look at this particular resistor, we can't decide the resistance value. Okay, that's what here. Physical size of a resistor, no indication of resistance. Even though it does give some indication of what is rating. By look at this, by look at the particular resistance, with the help of the size, we can decide the somewhat indication about the wattage. Maybe it is high watt resistor or low watt resistor based on the size. But based on the size, you can't decide the resistance value. That's what here mentioned. For a given value of resistor, greater physical size, higher the power rating. Okay, for example, greater the physical size of the resistance is greater, we can indicate that higher rating of resistor, that is, we can assume that is a higher rating resistor. Next one, power rating resistor. That's what. Higher wattage resistor can be operate higher temperatures. That's what P is equal to I square R. It can be withstand for higher temperatures. Moreover, higher power rating allows the higher voltage ratings. This rating gives the highest voltage may be applied across the resistance without any internal arcing. In this particular high power rating, obviously it is capable to withstand higher voltages without any arcing. Arcing means somewhat spark will be occur in the circuit. Without sparks, we can our circuit is safely if you are using the high rating resistors, suitable rating resistor in the circuit. Next one is a value of tolerance. For example, I am a manufacturer. I manufacture the 1000 ohm resistance. But I not promise that is actually 1000 ohm resistance. It may be tolerance of 10%. Tolerance means the value of the particular resistance is not exactly same, maybe more or less value from the marked value. So that's what here. Tolerance means it is a possible variation of normal value or marked value. For example, I marked value of 100 ohm with help of the color coding, but I mentioned that in the color coding itself, plus or minus 10% tolerance is there. The manufacturer decided. It means that actual resistance may be greater or less than the indicated value. So for example, in this case, 1000 ohm resistance, this is a 10% tolerance. That means if the resistance values from 900 to 900 ohms to 1100 ohms, right? That's what here. So if the value is 900 ohms to 100 ohms in between. So 100 ohms is more or less than the rated value. Okay. So next, carbon composition resistors having tolerances. Just now we see in the previous video, we see resistance, carbon composition resistance, wire wound resistance, right? So carbon composition resistance tolerance usually 5% plus or minus 10% plus or minus 20%. And then whereas generally wire wound resistance tolerances are plus or minus 5%. Okay, these are the points you need to remember. Okay. Next one, variable resistors. So here the name itself, it is a variable changing. So how it is, just look at here. In case in this particular for example, you want resistance between 0 to 10 ohms you want in between. So this particular resistor is very useful. That's what here. These are the resistors whose resistance can be changed from 0 to certain maximum value. The maximum value based on the resistance you are using. So generally, two types of resistor we discussed earlier, that is a wire wound as well as carbon resistors. These are the two resistors we have. So now how to change this resistance value? So look at here, in this particular diagram, these are the three terminals we have, A, B, C. For example, the A is a fixed terminal and then B is a moving terminal. This particular portion is decided the resistance. R is equal to rho L by A. That means R is directly proportional to length. Here length is less. What about the resistance value is a minimum. Now I am moving to this particular moving terminal towards the C terminal. So whenever it is moving towards the C terminal, what will happen? The length going to be increases between A and C, A and B. So length increases between A and B. That means A and B having more resistance. And if you got my point, whenever it is moving towards the clockwise direction, A and B resistance increases. What about the A and C? A and C length decreases. That's why A and C resistance is less. So it is possible now the resistance is varying with help of this particular rotating terminal is rotating, the resistance is varying. So this is a representation is like A, B and C. So this is also another representation of this particular variable resistance. How many terminals we have in the variable resistance? 3 terminals. That is also important. Another thing, for example, this particular moving terminal B is moving anti-clockwise direction, right? So in that particular case, so initially we have a resistance between B and C. It is a minimum length. So B and C value resistance, whenever it is moving clockwise direction, what happened for B and C resistance increases. Okay, B and C resistance. Here also B and C. I'm sorry, it is B and C. Correct it. Okay. What about E and B resistance? E and B resistance decreases whenever it is a clockwise direction, whenever it is anti-clockwise direction. Okay. This is a representation for A, B, C, and then this arrow represented this particular moving terminal is moving towards the A terminal or towards the B terminal. This particular arrow is represented. This is about variable terminals. All of you got my point? Now, so what about the ratings of this variable terminal? These variable resistors are generally we are using the carbon variable resistor, for example 1 by 2 watt to 2 watt in between. So the resistance value is 1 kilo ohm to 5 mega ohm. That means 1000 ohms to 5 into 10 power 6 10 power 6 ohms. That variable resistance is possible if you are using the carbon. Their power rating should be 1 by 2 watt to 2 watt in between range. So what are the applications? Commonly used in radio receivers as well as on off switch. Fan regulator also, this type of structure is there, variable resistor. In a olden days big box is there. In that you are call it as a regulator. In that the same structure will be, we are step by step we are moving, the fan speed is increases and decreases based on that, right? So this is a variable resistor concept. I hope that everyone is clear, right? Next topic is the potentiometers and rheostats. Okay, so here these potentiometer and rheostats are used to control the voltage and current. Very, very important. What is the use of potentiometer? To control the voltage. What is the use of rheostat? To control the current. Generally, these variable resistors are carbon or wire wound resistor. These two types of resistor we can use as a potentiometer and rheostat. Everyone remember these 2 points: potentiometer to control the voltage, rheostat to control the current. Let us discuss how it is happened, how to control the voltage in case of potentiometer. Let us take the potentiometer. By look at this particular configuration, this is a representation for potentiometer. How many terminals we have? 1, 2, and then this particular terminal is a variable terminal. So in this case, these two ends are connected to the circuit in circuit A and C and A. This particular B is a moving terminal. Whenever this B is a moving terminal, this particular we are given the 6 volt, right? Whenever it is moving off of the particular rheostat, a particular potentiometer, what about off of the 6 volt? That is a 3 volt. So whenever sliding this particular arm, that particular arm we are moving, then you can control the voltage. So we can control the voltage by moving B terminal in this case, right? Based on your requirement you can move. So in case how this particular potentiometer useful in the practical applications, we'll see. For example, you want to control the volume. For example, we have a give audio input in the input side. You want to control the output as a volume audio. So in this particular case, you are given the input is a audio. Whenever this particular wire is moving, this particular audio output is controlling. Whenever you want maximum audio, this particular moving element placed at A, you will get the maximum audio. So at A, we will get maximum audio. Next, in case we are that particular point moving at towards the C, you will get minimum audio. Okay, so all of you following? So in case of potentiometer, we are not only using the control of voltage. This potentiometer can be indirectly used to control the voltage, indirectly to control the different type of applications like audio applications. You want to regulate the audio in radio receivers. In case of radio, you are adjusting this particular tuning the channel and increase the volume or decrease the volume. This particular potentiometer is one of the application there. Next, one more thing, by look at this particular diagram, this is a input, audio input. For example, small disturbances in your audio input, so we can connect the capacitor. So whenever you connect the capacitor, whenever high frequency signals are passed through the ground through B terminal. Whenever it is moving towards the A, the maximum high frequency signal to the ground. In case it is a bypass, right? Bypass the signal. So it is a base. You call it as a base. In the volume itself, we can see base, we are increase the base terminal in the radios or tape recorders. We have one terminal is there. You can remember, you can visualize that in the practical applications, right? For example, this particular moving terminal toward the C, what will happen? This total entire resistor coming into this circuit. So terrible voice, that means some noise will be appear in your audio. So based on this controlling this particular potentiometer, in this particular case we can smoothen the voice, and we can what we call audio output quality can decide based on this particular variable terminal. We can move it where we get the clear audio, we can place that potentiometer that particular position. Okay, this is the way we are controlling the audio signals also. So finally, these are the potentiometers are using in this particular electronic circuits. So we'll see in the examination point of view, we need to remember what is the application of potentiometer. The application are commonly used in very important control devices, where everyone note down control devices in amplifiers. Okay, this is the first one. Second one, TV sets. In case of TV sets, we are using the potentiometer, and various types of meters, Next one, some of the applications are like volume control. Just now I explained volume control and tone control. So just now I mentioned this is a tone control circuit, right? We can control the tone of the particular volume. We can use the potentiometer, as well as balanced control and linear and brightness control. Linear and brightness control in TV receivers. Linearity and brightness control. In TV receivers. Why I am giving all these points in the examination? You are preparing for your exam, right? So first learn the concept, and then what you expected they will ask. They might be asked the questions. What are the applications below the applications for potentiometer? They mention all these and all of the above. You can choose that. These are all the applications. Then you can attempt the question properly. Okay. Next we are moving to the rheostat. Just I mentioned rheostat are useful to control the current. So very important. In case of potentiometer, I will write one point here. In case of potentiometer, to control voltage. Okay, important point. In case of rheostat, to control current, right? So look at here. In this particular rheostat, we are connected to the lamp. So this particular A terminal connected to the moving terminal directly. That means whenever moving terminal is moving, for example, this moving terminal here, everyone listen carefully. Moving terminal here, this particular portion resistance is not included in the circuit. That means whenever you are regulating, whenever you are moving this particular rheostat, resistance may vary. Whenever resistance vary, what about the current flowing through this particular bulb may be increases or decreases. If you want to increase the particular lamp brightness, what will happen here? Decrease the value of resistance here. That means it is moving towards the B terminal. Whenever you are moving towards the C terminal, the brightness going to be increases. This particular B terminal moving towards the A terminal, brightness going to be decreases. So based on the resistance value, based on the moving terminal, we can decide at the lamp. Once again I will repeat. For example, this B terminal at this particular point, what about total entire resistance is neglected, entire resistance is cut down, and the A terminal directly connected to the C. That means total entire current power supply appears across the lamp will be going very bright. So next, this particular B terminal connected at towards the A terminal, that means this A terminal total entire resistance is included. Whenever entire resistance is included, what will happen? So brightness going to be decreases. The current value flowing through the particular lamp will be decreases. That's what. Okay. In by look at this particular diagram, particular figure, in your laboratories, in your motor control or speed control of DC motors, we are using this type of rheostats, right, to control the motor speed, as well as this particular rheostat act as a load also. Some particular cases we are using this particular rheostat. So in the size of the rheostat and size of potentiometer is very high in case of high power rating. If you are designing for a high power rating, the size will be also high. Now my question here, this particular rheostat you can use it as a, for example, with you potentiometer is there, you can use it as a rheostat. Yes, that's what we'll see. In case I have a potentiometer, I can use it as a rheostat. In this particular case, this is the A terminal, this is the B terminal, and then this particular, for example, this is the C terminal, this is the B terminal. This particular structure, we can make this particular potentiometer make this type of connection. It is act as a rheostat. Another connection is like particular potentiometer is connected two ends A and B, and then here B, A and C, here B is connected here. This type of particular connection also we are doing for potentiometer. We can convert potentiometer into rheostat. So finally everyone is clear about the potentiometer and rheostat. So this is the explanation is enough for the potentiometer and rheostat. In the objective questions, while you are preparing the test series, we are taking some questions based on that. Then you will get the idea. So then we are moving to the feasible resistor. So the name itself, fuse, what is the purpose of fuse? To protect the circuit, right? So this particular feasible resistor is also same function of protecting the circuit, right? These are the generally wire wound devices, wire wound resistor. Look at here, these are the feasible resistor, generally wire wound devices. Similarly, ordinary wire wound resistor appearance is just like ordinary wire wound resistors, but sometimes you use it as a amplifier and TV set to protect the certain circuits. Just now I mentioned feasible resistor is to used for the protection of the circuit. Okay, so they have a resistance less than 15 ohms. Generally we are using this type of resistor, the value is 15 ohms, less than 15 ohms. We are designing this particular resistors. Next one, cartridge fuse. In place of cartridge fuse, this also designed, this particular fuse also designed whenever the current is exceeds the certain predefined value, so it is going to be burned. That resistance going to be burned. Burn means that you are protecting the circuit, right? Whenever you design the particular circuit for 10 amperes, current will be flowing more than the 10 amperes. This particular resistor going to be cut down the resistance from the particular 15 or 20 amperes more than the predefined value. Then it is used as a fuse. That's why it is a feasible resistor. Okay, this is what related to the feasible resistor. Okay, next one is a resistor color code. So this is one of the important topic. You may expect one question from this particular topic. So everyone listen carefully. So here resistor color code. First I will make some table for you. Everyone by heart or remember this particular table. In case of color, the value. In case of black, 0, brown 1, red 2, orange 3, yellow 4, green 5, blue 6, violet 7, gray 8 and white 9. So in your college days, while you are studying in the college, they will give some code to remember these particular values. The code in my college, my teachers give the code is BB Roy go to Bombay via Goa to Ave. This is a code. I remember all these values. maybe which code you are comfortable, we can use those code to remember these values. Once again I will repeat, BB Roy, I will write here BB Roy go to Bombay via Goa to away. This is the code I remember. So BB Roy, whereas the capital letters is there, those letters it is make the sense. Okay. So let us discuss. I will take some examples, then we'll discuss this particular 4-band and 5-band resistor. Okay. Before I'm going to explain these particular examples, we'll see the background, how to this particular resistor value mentioned in this particular color code. We'll discuss the basics first. Okay. Right here, see, resistance color bands. So in the resistance, top of the resistance, okay, it is mentioned some colors. Okay, these colors may be 3 bands are there, 4 bands are there, 5 bands are there. Okay, we'll see one by one. So here, how many bands are there? 1 2 3 4 4 bands are there. Here also 1 2 3 4 bands are there. That means in case of color bands, maybe 3 bands are present, 4 bands are present, 5 bands are present. So what are the each and particular bands, what represented, we'll see. So see here, these are the bands are printed around the body of a resistance near to the end. Each color stands for a digit. Okay, every color stands for a digit. Just now we saw some values: black 0, brown 1, red 2. That means each color represented the particular digit. Okay, often there are 4 bands, sometimes they may be 5. Just now I explained 4 or 5 will be there. In each case, the first 3 bands, very important, first 3 bands gives the resistance value. First 3 bands give the resistance value. Let us see here. The first band, just first digit. That means what are the color may be represented, that color may be the value what you got from the table, we can directly mention in the value here. Second also digit only from the table. So these 2 are digit. Third one is a multiplier, decimal multiplier. For example, here band 3 is a red, right? So what is a red color value? 2. So here red color value 2 means that 10 power 2. That's what here. Decimal multiplier. Got my point? In case of this is a blue color, violet color is a 7, right? So violet color is a 7 directly digit. Okay, next one, first band is a white. So what is a white color is a 9. So it is a 9 directly. So you got my point. 97 into, it is a multiplier. So 97 into 10 power 2. Next one, tolerance. So fourth band is a tolerance. For example, this particular fourth band tolerance can decided where, for example, it is a gold color plus or minus 5%. It is a silver color plus or minus 10%. In case of there is no color, it is also happened, right? That particular case, there is no color. Everyone note down, no color. That means no band plus or minus 20%. All of it clear? You got some idea? Then we are moving to the one by one properly. So 3 bands only. For example, 3 colors are there. Okay, they are represented the resistance value as per the color code. The absence of 4th band, just now I mentioned absent of 4th band. There is no 4th band. There is no color in the 4th band. The tolerance is 20%. Next, 4 bands only. In case of 4 bands are present, as before, 3 bands gives the resistance. Just now I mentioned 3 bands gives the resistance. The 4th band gives the tolerance. In the 4th band, maybe gold ring is present. What is the tolerance value? Plus or minus 5%. In case of silver ring means what is the tolerance? Plus or minus 10%. If it is 4 bands are present. If there is no 4th band, it is a plus or minus 20%. Next, in case 5 bands also there. Maybe in your college days you don't know the fifth band concept, and maybe they won't explain there, but you can see just fifth band is also present. What is the fifth band? The fifth band here, first three bands usually gives the resistance, fourth band gives the tolerance, fifth band gives a reliability level, that means failure rate. So for example, you are using particular resistor, what is the failure rate? It is represented in the fifth color. For example, brown is a fifth color, that means failure rate is 1%. 99% is okay, 1% maybe chance is there to failure the resistance. In case of you are using the fifth band is a red color, only 0.1% is a failure rate. In case of orange, what is the failure rate? 0.001%. In case of yellow, it is a value is 0.001%. That means which resistor is the best one? Yellow resistance. Yellow fifth band is a yellow. That resistance is gives a maximum safe value. Failure rate is a minimum. That's why it is a good resistor. Okay, this was fifth band. Clear? Now, so what I gave the explanation, summarize here. The first band closest to the edge indicated the first digit numerical value of the resistance. Second band also gives the second digit. These 2 points are clear. Third band gives a decimal multiplier, that means 10 power 2, 10 power 3, 10 power 4. For example, it is a black. The third color is a black. What is the black value? Is 0, right? Whenever black value is 0, 10 power 0, what is a 10 power 0? 10 power 0 is equal to 1. Right, that's what your third band. Third band is a decimal multiplier. It gives a number of zeros after two digits. It is important note that third band is a black. For example, third band is a black. It means do not add 0 to the first two digits. That means 10 power 0 is a 1 only. So the resulting number is less than number is a resistance of the ohm. That means 97 in the previous case, 10 power 0, that means 97 only, because 10 power 0 is 1 into 97, 1 only. That's what there. Next, fourth band gives a resistance tolerance. There is no fourth band tolerance. You should understand that plus or minus 20 ohms. So look at in this particular case, the first one is you can't properly see, yellow. So first one is yellow, it is a 4 digits directly placed. And then second color is a violet, it is directly placed 7. And third color is a orange. Whenever it is orange, the numerical value is a 3. Look at here. Orange numerical value is a 3. So whenever orange numerical value is a 3 zeros are present. And then last one is silver color, plus or minus 10%. Finally, resistance 4, 7 side by side. Multiplier 10 power 3 plus or minus 10%. That means 47 kilo ohms plus or minus 10% is the answer for this question, for this example. So everyone is clear about how the value of resistance is measured, right? So further we are moving some discussion. 2 points are there. For example, resistors under 10 ohms. That means in the third band either gold or silver. In case of gold or silver in the third band. In case of third band, black to your black is 0 and then brown is 1. Like in case of gold is there, how to take those values, right? That is also there now. That's why here look at here. In case of gold or silver is there mentioned, is there present in the third band, it is a fractional multiplier. Fractional multiplier means if the third band is a gold, everyone 0.1. Third band is a gold. What is the multiplier here? 0.1. That means 10 power minus 1. That is a 0.1. Next, silver is a silver. It is a multiplier is 0.01. It is a silver. Third band is a silver 0.01. That may be equivalent to 10 power minus 2. However, the fourth band, as before, gives a tolerance. Fourth band may be gold or silver or no color. That gives the directly tolerance only, plus or minus. The special case in the third band, maybe gold or silver is there. The multipliers are fractional multiplier, 10 power minus 1 and 10 power minus 2. That point you need to remember. So in this particular example, it is a blue, it is a white, it is a silver. In case of blue and white, what are the values? See. So blue and white. Blue is a 6 and white is a 9. Six and 9, right? Next, what is the color? Gold is present. Whenever gold is present in the third band, it is multiplied by 10 power minus 1, right? That means 0.1. Plus or minus. Silver is present. Silver is a plus or minus 10% tolerance, silver carry. That means 6.9 plus or minus 10 ohms is a value for this color code. Okay. Next, in case this is a third case. For example, the colors are not visible properly in the resistor. How to measure the resistance? So that's what here. A common trouble with the resistance is open. The maximum trouble is resistance open. So which happens whenever it is happening, excessive current and heat. Excessive current and heat will be produced in the resistor. It may be get open circuited. For example, it is a charted or discolored resistor would be discarded. Straighten the way through, it will be usually checked good with the ohm meter. In this particular case, there is no color properly. We can use ohm meter to measure the resistance. So one more important point, which of the following meter measures the resistance? Options are given: A ammeter, B voltmeter, C ohm meter, and D none of the above. Which of the option is correct? Ohm meter is a correct option. Okay. Another important topic, next topic, checking resistance with resistors with ohm meter. So this is the last topic from resistance concept. The passive circuit elements, we are divided videos in the 3 parts. The first part is a resistance, second part is inductor, third part is a capacitor. In the resistor, this is the last topic. So checking the resistor with ohm meter. While you are checking the resistor with ohm meter, external power supply is not required. Right, because in the ohm meter itself the batteries are there, voltage source is there. So look at here first diagram to measure the resistance value. So external source, I'm not connected any external source, that's why it switch is open. Now I'm going to give the explanation related to the particular ohm meter, then we are moving to this particular circuit. So in this particular ohm meter, the scale is calibrated. The scale is calibrated related to the ohm scale. What is the scale here? Ohm scale is present. Ohm scale is present. For example, your scale is designed from, for example, it is 100 ohms to 1 mega ohm. 100 ohms to 1 mega ohm, your scale is designed. But in case of resistance is unknown resistance, you are connected to ohm meter. You don't know the resistance value, maybe that is a 1 mega ohm or 2 mega ohm or 100 mega ohm, you don't know. For example, this particular 10 mega ohm resistance, example 10 mega ohm resistance connected to the ohm meter, but this particular ohm meter is designed for 1 mega ohm. What happened in this particular case? So in the examination, they will ask this type of questions. What will happen? This particular point shows as infinity. That particular point shows as a infinity. Infinity point here mentioned, the value of resistance more than the scale, the rating of the volt. That means this particular ohm meter rating, that scale is 1 mega ohm is a maximum scale. Full scale deflection is a 1 mega ohm. So more than that we are connected, what will shows the pointer infinity. Okay, once again I will repeat. Whenever the ohm meter is designed for full scale deflection of 1 mega ohm, if you are connected the 10 mega ohm more than the 1 mega ohm, the pointer shows the infinity. Okay, that is a point you need to remember. Next, in case this particular ohm meter is starting from the 100 ohms, right? But you are connected 10 ohms. For example, this ohm meter is designed the minimum value from the 100 ohms, but you are connected to 10 ohms. What will happen in the particular ohm meter? This particular ohm meter shows the 0. Particular ohm meter shows the 0 point. 0. That means it is a short. So that's what here the particular ohm meter, based on the predefined values, in between the resistance values there, it shows the value. Okay, next, how to measure this particular resistance? See here, For example, I want to measure the resistance of 10 kilo ohm, this particular resistance. For example, this 10k, both are connected in parallel or not? Whenever both are connected in parallel, what about the equivalent resistance between these two terminals? You know, theoretically, R1 into R2, 10k divided, these are the two equivalent resistance, 10 by 2. You know one formula, whenever both the resistors are equal, n divided by 2, right? Both are 10k, both are equal, so one of the resistance divided by 2. One of the resistance divided by n here, n is a 2 elements, that is a 5k. What you may, this particular ohmmeter reads 5k. Clear? That means while you are finding in the resistance value, you want to measure the single resistance alone. So in that particular case, you disconnected the 10k from the circuit. Only 10k is connected to this particular ohmmeter. In that particular case, the reading is 10k. All of you got my point. That means this particular ohmmeter, if you want to measure the total entire equivalent resistance of the circuit, this is a way connection. You are connected to total entire circuit. You want to measure the only particular resistance. First, disconnect the circuit from this particular resistance. Connect the ohmmeter separately. Then it measures the correct value. Maybe you recall in your experiments, in your EDC experiments, while you measure the resistance value in the before placing the PCB. Okay, we are measure the resistance value outside and then we are connected to the circuit. Okay, otherwise we will get the wrong values. Maybe equivalent values, you are parallelly both are right. Equivalent is 5k. Whenever you are connected separately, it is a 10k. Okay, got my point, everyone? Right. One more important point I'm going to mention here. While you are measuring the resistance value, don't touch the terminals of ohmmeter. If you are touch the ohmmeter terminals, what will happen? Your body resistance also connected parallel with the measured resistance. That means whenever parallel resistance going to be decreases. So what is the actual value? That may be decreases the true value. The actual value going to be decreases whenever you are touching the terminals of ohmmeter. That is also one more precautions. But it is not dangerous, but your measurement going to be error while you are touching those two terminals, while you are measuring the resistance of particular resistance by using ohmmeter. So I hope that everyone is clear about ohmmeter measurement. Okay, this is enough for the examination point of view. What are the questions you may expect? These two questions may expect in the examination. Note down in your notebook. One more question: what is a meter useful to measure the resistance? Ohmmeter. Another question you may expect it. Okay, thank you.